Hello and welcome to this RCR Wireless webcast. I'm joined today by several experts, and we are going to be discussing LTE device testing, LTE device testing procedures, and just in general the trends and challenges that are facing LTE device testing these days. So our participants today, along with me, Kelly Hill, technology reporter for RCR Wireless News, are Amit Malhotra, Vice President of Marketing and Product Management for Azimuth Systems. Welcome, Amit.
Thank you.
And we have Carl Anderson from Anritsu, who is Senior Business Development Manager. Carl, welcome.
Thank you, Kelly.
And we also have Mike Thorpe, who is a product manager for Rohde and Schwarz. Welcome, Mike.
Thank you, Kelly.
This program is part of a three-part series on LTE device testing that consists of a special report, which is available for download on rcrwireless.com. Last week's webinar that includes a PowerPoint presentation on the topic, and then today's discussion, which is again, a dig deep into some of the challenges and the issues going on in LTE device testing today. So with that, we're going to go ahead and jump straight into the conversation. Mike, I wanted to start off with you and ask, as wireless technologies are evolving, has the relationship between test and measurement companies and their customers evolved?
Yes, Kelly. Speaking for RNS, I would say absolutely yes. The complexity of wireless networks continues to increase. Not only is there the addition of multiple cellular technologies, also multiple bands. With that, there's also the connectivity market, so the Wi-Fi, Bluetooth, all being supported within the modern device. As companies involved in delivering products to this ecosystem, they're looking for not only just a box. A test solution needs to also include training, technical support. In other words, they're looking for expertise that needs to be delivered to them. RNS's position is to be a customer consultant, providing not only product-related information, but also technology updates and industry trends to help our customers.
Okay, so it sounds like that relationship has grown closer as the testing complexity has grown.
Yeah, there's a definite need for closer alignment to ensure that both parties are aligned with the upcoming trends and rollout strategies.
Okay. Carl, going to you, how do you see testing being changed by the introduction of LTE?
Well, I think that one of the things that happened is that when LTE was designed in the standards organization, there seemed to be a bit more of an eye towards testing that happened as it was being designed from the ground up, which I thought was a noticeable departure from the previous technologies that I've worked on. I also think that the nature of LTE being more aligned with being a dumb pipe, although none of my customers would be happy to hear me say dumb pipe, the real usefulness to the consumer is generally on the applications that ride on top of it at the IP layer. So there's been a lot of separation from the overall air interface to the services and the features that are supplied, which means from a testing perspective that we can test for many different feature types by testing the basic connectivity, the protocol, all the RF stuff that we normally know and love, and then tie the features and the services to testing above that. So I think that's a pretty big game changer as far as I'm concerned. It makes some things easier and some things a lot more difficult. But it's always more fun to do it differently rather than the same way we've done it several times before.
Okay, good. Amit, I wanted to come to you. Now, Azimuth highlights mobile performance testing as opposed to some of the conformance testing or carrier acceptance or certification testing that are done at various stages of the LTE device launch process. So what do you folks mean when you say mobile performance testing?
All right, first of all, I'd like to apologize for any volume issues here, so I hope you guys can hear me all right. When we talk about performance testing, it's really an indicator of the increased amount of competition across the industry. So one of the things your report highlighted was the fact that there were 680 devices introduced last year alone. That's a massive number of devices hitting the market, and given the fact that the mobile marketplace is getting pretty saturated, these devices are all kind of fighting it out, not just as OEM offerings, but as operator offerings as well. So what's become much more important is not simply that a device conforms to the specifications of a standard, but how it actually does in the marketplace, especially relative to the competition. So while conformance is, that it meets a certain specification, performance is about how much it meets or exceeds competitive benchmarks as well as customer expectations. So, we put a lot of emphasis on being able to accurately predict performance out in the real world, so that our customers can make design changes and can also, better understand what the acceptance of the product is going to be once it gets into subscribers' hands.
Okay, great. Carl, I wanted to come back to you and talk about test automation. One of the things that really struck me as I was working on the special report was the amount of testing that needs to be done, especially when you start talking about the smartphones, tablets, more advanced devices that have more features and are requiring more testing. So how important is the automation of those tests, especially when we start talking specifically about the device under test?
Well, I think that that's critical to the success of anybody's testing program, and the issue is that it's a real industry-wide challenge. It's not necessarily a challenge for just one operator or just one OEM or just one operating system type, but it's really the same challenge for everybody. What I always talk about as being the ideal test regimen is you plug the device into the test equipment, you hit go, and you come back however much time later and hit print or save. And if you can do all that, then you've got a pretty good testing program. The difficulty on there is that you have to control the device for some things. You also have to be able to look at the device to see what's on the screen. Because if you're testing video throughput or something, how do you know what's truly coming out on the screen? And if you want to send an SMS or something, how do you do that without having a human being in there pushing buttons and sitting around bored silly for 25 minutes till they get their 3 seconds of fame? So it's really critical in order to have a good program. But the challenge is that we have multiple devices with multiple operating systems. Fortunately, everybody seems to have the same type of cable to connect to them pretty much. But a message that might go to operating system A might not work for operating system B. So how do you manage all this as a test house or an operator running the tests, as a test equipment vendor? I know Mike and I have chatted about this from time to time in industry meetings. How do you handle all this to make it go easy and not have to have a bunch of specific stuff for a particular device? So I think it's critical, and it's a really good challenge.
Okay. Well, then, Mike, following up on that, I want to come to you and ask about simplifying testing and how you think the test and measurement industry can really help to simplify the test process. And obviously, automation is part of that, but what else?
Yeah, this leads on nicely from what Carl was mentioning about automation. What I would say is one key element in simplifying the test process is to minimize the expertise required to operate the equipment and to interpret the final pass-fail result. Engineers trained on specific test equipment often switch roles within a company or sometimes move on to different companies. Therefore, it's critical that many technology and applications can be covered within the fewest possible pieces of equipment due to different boxes typically have different user interfaces or different APIs for control. Minimizing this is critical to get engineers up to speed and doing useful testing in the lab immediately. Another item is user interfaces can be enhanced to provide graphical tools with built-in rules based on the standards. This helps to reduce the error and also the expertise required by the test engineer of either the standards or the test equipment. Finally, the GUI needs to simplify the process of determining the pass-fail result. The test engineer doesn't want to have to sort through numerous log files, decode multiple messages to try and interpret the result. This can lead to error. Therefore, minimizing this and providing the simplified pass-fail result verdict is key.
Okay, great. So we've talked a little bit about simplification now. Amit, I want to come to you and ask about what innovations you see happening in lab-based testing of LTE devices.
Okay, so actually simplification is a key aspect of that, because one of the things that's happening in the real world is basically increasing complexity at pretty much every level, whether you're talking about the network or the device, services and applications over that device, and those individual developments can really explode the scope of testing, which very quickly becomes manageable. So one of the key things that we see happening from an innovation standpoint is that increasingly the focus of testing needs to be user experience measurement, not simply network level KPIs such as throughput. Because at the end of the day, as we talked about earlier, performance is really key. So knowing that two devices, one performed a lot better than the other from a user standpoint is going to be really critical. And then once an issue is identified, then on an exception basis to try and trace it back through network device analytics to what the root cause might be, whether it's on the device side or it's on the network side or some other element. Another type of innovation is basically to try to get ever closer to real-world conditions in the lab. So, a lot of testing is done via conducted methods using something like a channel emulator, where the device is actually, physically cabled to the test equipment, and the network information is fed to the device straight to the RF port, bypassing the antenna. Well, that's not really real-world testing. It has been very effective over the last several years, but what the industry really is starting to move to now is over-the-air testing, or OTA, in which basically, the device is being fed the network information through its antenna in a shielded chamber so that you isolate it from other sources of noise. So if you apply the same type of testing, but you actually can utilize the device in its natural state, which is to say using the antenna, and then apply user experience automation, the way Carl was talking about, so that you're also exercising it the way a subscriber would. And then lastly, you're applying network device analytics so that when an issue arises, you can quickly figure out what's causing it and then make some decisions, such as a design change. Those are the types of innovations that we see happening in the lab.
Okay. Okay, so addressing innovation. And then, Carl, a question on what hasn't changed. There's still a lot of things that need to be tested, and some of them have been the same for a very long time.
Well, your basic conformance hasn't changed. Obviously, the nature of the protocol has changed a lot since back in the AMPS days for those of us in the U.S. But you still have to test and make sure that the radiation that comes out of the device doesn't splatter into somebody else's spectrum. You still have to make sure that the FCC or any other agency, wherever the device happens to be deployed, will not be upset. You have to make sure that you're not interfering with your neighbor. And so that hasn't changed, and that probably never will change. It's what's really changing is the way, getting back to what Amit said about the user experience. Because the user experience in this device that we could go buy at the store today is so much different than the one you could buy 10 years ago, 20 years ago, or even 30 years ago for those of us who can remember buying devices 30 years ago. So the basics of does the device work, that hasn't changed. And as I said, probably never will.
Okay. All right. So now that we've addressed some of these things, I want to talk about some of the specific features and services that we're starting to get into. Definitely with LTE, and also some of them having to do with LTE-A. But specifically, I want to talk about VoLTE. Mike, my question for you is, what are some of the specific test challenges that are brought on by VoLTE, Voice over LTE, and IMS?
On this topic, it's important to remember that VoLTE is a major shift for carriers. The existing rollout of the voice service is based around circuit switch connectivity, and this migration to VoLTE involves moving to an all IP based voice service. With this technology shift brings additional technical challenges which must be addressed ahead of launch, especially when end users already have an expectation of voice quality and call reliability. Remember, customers will not be happy with a service that is less superior, i.e. more dropped calls, failed handovers, or even poor audio quality. With this in mind, carriers are taking the VoLTE deployment very seriously. To mitigate risk, carriers are taking ownership to define supplementary test plans aimed at testing above and beyond what's defined in the conformance test requirements. If I delve a bit deeper into this, some of the areas of test of interest revolve, like Carl mentioned, it's still the same core areas that they're involved around the protocol and signaling aspects, but with VoLTE you also have the addition of the IMS signaling, and on top of that you have supplementary services which wraps up RCS, things like presence, interactive phone book, video conferencing, etc. And then beyond the protocol and signaling aspects, there's also quality and performance that needs to be verified. There's the VoLTE audio quality, making sure that the audio quality is of the correct level. And then beyond that, there's also audio performance, looking at things with IP impairments and jitter and delay and packet loss. How does the VoLTE call stand up to these types of impairments? And then, as I mentioned earlier, VoLTE isn't just voice. There's also video telephony. So you can look at things like video performance and how the camera and the front camera, the back camera, how all of these things perform with packet loss or fading conditions or noise. And then I'll probably expand on that as well and say the migration to VoLTE doesn't just impact these basic calling functions, but also there's an impact on E911, which is the emergency calling and how this is handled. You can start to deploy E911 over IMS technologies. And then with this, the location-based services aspects could be handled via the control channels of the LTE network using C-planes, what it's known as. Or alternatively, location-based services could be deployed over U-plane using a protocol known as SUPPLE. But I think the main thing, the bottom line is to remember that no matter what approach is adopted, the FCC regulations and the minimum performance requirements still need to be met.
Okay, absolutely. Amit, when we spoke for the report, one of the things that we touched on was VoLTE, and we had several U.S. operators who had announced plans to roll out VoLTE, or at least have it network ready by the end of 2013. Nobody has launched services except for Metro PCS to this point. So do you think VoLTE is ready for prime time?
So if we define prime time as that it's widely available in the market and that numerous devices are coming on the market that offer VoLTE capability, and it is a service that's offered by the operators, we're nowhere near that right now. And to be fair, it's simply because it's really hard to do. I mean, if we think about, the expectations for VoIP on the wireline network many years ago, how did that play out? So for us to think that, VoLTE is going to be something that's easy to get off the ground, it's clearly not going to be. So, where it is today, there's obviously been a tremendous amount of network testing that's been going on, and I would say that, that's still underway. And a lot of that has to do with the complex interaction between the different elements of the network, including the IMS and the LTE network, and so on. But more importantly, for purposes of this discussion, devices are still not fully. Well, let's just say that devices that are out there, I would think of as kind of more prototypical in the sense of, they're taking proprietary approaches to implementing VoLTE from one device to the next. And what complicates testing is that you can't really automate two devices because they're both, doing things slightly differently. And so as a result of that, the operator and OEM test plans are still in the formative stages. That means that, whereas there's test solutions on the market, they're not necessarily fully calibrated to the way devices, need to be tested, once the service is completely launched. So I think that, for us to sort of, as an industry, to be at the prime time is going to be another 6 months. You certainly may have. First of all, I do believe that there's devices that are on the market right now in subscribers' hands that are VoLTE capable. They just haven't been enabled because the service isn't offered. So that service will start to be offered, but again, those devices will still be first generation. It'll be another 6 to 12 months before you've got a lot of devices offered by multiple operators that you can sort of consider it a ubiquitous service.
Yeah, I think the latest numbers from the GSA were that there were 30-odd VoLTE capable devices, and as you mentioned earlier, that's out of more than 600 LTE devices that were launched in the past 12 months. So you could, just from those numbers alone, you can kind of get a sense of scale on LTE versus voice over LTE. Mike, I wanted to come back to you. You mentioned location-based services, and I wanted to follow up on that and ask about some of the significant changes that are happening in LTE when it comes to location-based services. Can you tell us more about that?
Yeah, location-based services for LTEs, it's an exciting time right now for this particular application. There's lots of changes going on, not only in the LTE core spec, but also within the GNSS, the Global Navigation Satellite Systems segment. So to touch on a few, within LTE Release 9, there were additions to help with indoor positioning. So this revision of the spec includes the addition of the PRS, which is the position reference signal. This is transmitted from the eNode B and is used by the device to help improve indoor positioning. And it uses a positioning technique known as OTDOA, so observed time difference of arrival, where it takes measurements from multiple eNode Bs and their PRS signals. On top of this, there's also been some changes within the signaling of LTE with the introduction of a new protocol called LPP. This is the LTE Positioning Protocol, and this is used to start the location-based services session, stop the session, and also transmit and exchange the key assistance data that's needed in any AGNSS, any assisted positioning techniques, whereby you need to provide assistance data to help the UE find satellites and speed up the time to first fix. On top of that, in the GNSS domain, we're also now starting to see devices support multiple satellite systems. So previously, everyone mainly spoke about AGPS. So this is location-based services using the GPS satellites and taking measurements from the GPS satellites and using assistance data from the mobile network to help speed up the first fix. But now there's the addition of multiple satellite systems. So GLONASS, the Russian constellation, is also being used. So this helps the mobile because it provides more visible satellites in the sky. The device now has the choice to use either the GPS or the GLONASS or both and combine them in a hybrid style configuration. There's further developments going on whereby Compass, Beidou, the Chinese satellite system, could be used, and then obviously Galileo is another option. So there's lots of developments around here. And then on top of that, all of these key things can have an impact, like I mentioned, on E911 and how this interacts with VoLTE. what I would say is all of these changes bring additional test requirements in the domains of protocol, conformance, performance, for industry certification and for carrier acceptance. So yeah, it's an exciting time right now, and RNS is focused on working with customers and delivering solutions around this.
Okay. Carl, I wanted to come back to you. There was a blog post recently by Olga Yashkova, who's a test and measurement analyst for Frost & Sullivan, and she was talking about how test equipment will be needed for M2M applications, machine to machine. And I'm wondering, I wanted to ask you, what impact will this idea of the Internet of Things or monitoring everything have on device testing?
Well, this is where I see a real challenge that none of us are totally prepared for, and I mean that as an industry, not any particular company. When you have an M2M application, essentially you start with a module or something that's been designed by people who are experts in the wireless area, who then take it and integrate that into something that isn't a traditional wireless device, like your refrigerator or your stereo system, which actually happens a lot with Wi-Fi today anyway, or some monitoring system somewhere for something that nobody's ever thought of. Well, then you get back to what Amit was talking about. How do you test whether the fact that you've placed this module inside of a steel cage impacts its abilities to radiate somewhere? I mean, after all, a shield room and your stainless steel refrigerator have a lot in common. And and I see Amit's laughing because he's been wrestling with this problem a lot, I'm sure. And so when we talk about the Internet of Things, what it means is that a lot of players will come into the party because wireless is what's going to enable a lot of new services that none of us have ever thought about. And they bring experience on applications, but they don't bring experience on wireless. And so the integration of those two is really going to cause a testing challenge. It's going to keep all of us in business for a while longer, but it's going to keep us enjoying new things because this is new challenges. And so I don't want to say concerned because it's a challenge that comes, but it's going to be really interesting to watch how this plays out. And yes, we're going to have to test it, and we're going to have to get more inventive and innovative as to how we test things, because eventually you're going to have something that's just too big to put in a shield room somewhere to see if it's radiating correctly. So how do we deal with all that? And that's going to be a lot of fun and a lot of challenge, and it's going to keep us all busy until 5G comes along, and then we get to start all over again.
Well, and I think that's a really interesting point because, one of the things that that came up, and I think this was a conversation that I had with several people over the course of the report, was that there's a limit as to how much companies are willing to pay for the testing process. And there's a push-pull there between the amount of rigor that they'd like to see done to make sure that something works and the amount of testing that they have the time and the money to do. And I think when you start talking about the Internet of Things and very tiny little sensors and refrigerators and radios and, all different kinds of scientific sensors, the ROI there is very different than a mobile device. And I think that's it's going to be interesting to see how the industry goes about addressing that as well.
Yes, and it's something that's going to have to be addressed, because if you don't test it and it doesn't work, well, then you've got a product failure. And so you're going to have to balance that out somehow.
Yeah. All right. So I want to just touch on briefly the role of some of the standards bodies. And Amit, I'm going to toss this one to you in terms of how do standards bodies keep up with the industry requirements for new types of testing. Now, I know you guys specifically, focus on performance testing, but I just kind of wanted to get your perspective on how well the industry is keeping up with new types of testing as these new networks are evolving.
Okay. Well. We're engaged with several standards bodies, including 3GPP and CTIA. Right now, our focus is on the standards for MIMO over-the-air performance testing. There's a lot of activity to standardize that new innovation. But you know, what we also see is there's a lot of areas of testing that currently the standards bodies are not able to keep up with. What's happening as a result is basically that the operators, the OEMs, the chipset vendors, the NEMs, they're forming their own ecosystems and creating these de facto standards of testing that may be different from one ecosystem to another. And that's really, in our view, where the standardization is taking place. It's been happening a lot more organically, not necessarily following the order that the standards bodies are used to, but maybe because of the pace of technology innovation, that order is often not possible. And so, again, the de facto standardization is really taking place, within the industry itself, within these ecosystems I was talking about.
So something like along the lines of something, is it the same kind of thing where you end up with a Blu-ray versus an HD DVD? That kind of.
Potentially, although the players in the different ecosystems overlap significantly. So you have a lot of the same OEMs, for example, and they will force kind of more commonality than occurred in that particular instance.
Okay. Great. Mobile apps. Let's talk about that for a minute. And Carl, I'm gonna send this one over to you. Now, I think we've kind of covered the fact that, and I think it was you, Carl, talking about LTE as a pipe, and that a lot of the experiences that customers have come through mobile applications. So what do you see as the impact of mobile apps on device testing? And I think we especially see that, and I know I see it on my phone, in battery life testing.
Well, I think that apps is really, I mean, obviously that's what drives smartphone performance. You've got a similar thing to what I mentioned about the Internet of Things. You have a fundamental device, in this case, any of the smartphones that get tested, and they all test out pretty well, and we know what happens. And then you put it in the hands of a consumer who may not be as technologically oriented as everybody that's on this particular webinar or TV scene. And then they start adding them all up, and they start saying, oh, this is a cool app, I'm going to put this one on. This is a cool app, I'll put this one on. And every one of those applications decides it wants to check into a server somewhere periodically just because it thinks it's a good idea. And so you have this phone sitting in your living room while you're watching TV that's talking to the network, and every time it turns on, it starts to drain the battery out. And is this a bad device? Not really. Is this a bad user experience? Definitely. Is this a bad user? No. Is this bad app designers? No. It's just that you put all these things together and it starts to become almost an intractable problem. Because if you're designing a test regimen, I think that the OS vendors provide a pretty good way of testing out each application individually. They have rules about what they have to do, and there are rules about how often devices can handle certain accesses, but it's just intractable if you've got 50 apps on your phone all trying to do something. And battery life, unfortunately, tends to be the first thing that you notice, but it also impacts the actual performance, because if you're streaming a video and you've got 20 apps in the background, and I'm picking big numbers just to illustrate, you're streaming that video and 20 apps are also trying to grab bandwidth. Well, what happens? Something has to give sooner or later. And to me, that how we design a testing regimen to detect those kinds of things is really an industry problem. It's not an Anritsu problem. It's not an RNS problem. It's not an Azimuth problem. It's an industry problem, and it doesn't rely on just one operator or another. So the challenge is there. I'm not sure I know the answers. I'd like to think that me and my company will figure these out, but it'll be a challenge, and it'll be a lot of fun for all of us also.
Well, and I think that was one of the things that I think really came out of the report. I talked to some folks, including NSN, who are really trying to figure out how to get a handle on this. And it's going to be interesting to see how the industry does get a handle on this, because the app experience is so integral to the user experience. And it's also such an important issue when it comes to how well the network performs as well, because if you get a chatty app and all of a sudden you're getting traffic that is inefficient traffic, then you've got network problems along with user experience issues. So, Mike, your thoughts on app testing?
Yeah, I'd say there's another sort of domain to app testing as well. You know, as an end user, if you purchase a device, you preload certain apps which you want to use. You start using them on your new device, and you start to experience problems. You may return the phone, you know, claiming there's a faulty phone or something, maybe the behavior with the network. So it also impacts on the reverse logistics. So typically, you know, a device is returned and tests are performed whereby they check the transmitter receiver, check the modems talking to the RF. Now on top of that, with modern smartphones, you've got chatty apps. You could have a rogue app on a particular device. Without that app, the device performs well. So, you know, as a test equipment supplier, we're having to look into different areas of testing for apps. So, not only say in the R&D domain, but also in reverse logistics, and be able to diagnose, look at a device, probe what apps are running, look at the profiles and the processes that are being used on that device, and then determine whether it's a specific app that's demanding connectivity all the time, draining the battery. So yeah, there's exciting times ahead with the explosion of apps.
I know I wish I had that capability to diagnose on my own phone. Amit, do you have anything that you'd like to add in terms of app testing?
Yeah, actually, so you know, Carl said that basically that all apps, you know, are designed pretty well, but I have talked to operators, and they definitely don't see it that way. I mean, they see a lot of apps that are actually badly designed, and in many instances, they've brought down networks, and then the operator then is scrambling to fix the issue and ends up going to the oftentimes the OS vendor to get them to basically prohibit further sales of that app until the app developer makes some changes, and you know, particularly in terms of the way the app interacts with the network. So it is very much the wild, wild west out there. You've got the operators, the device vendors, the OS vendors, all trying to kind of create boundaries. They're not always very successful at that. So it's you know, what I've seen is that operators increasingly are taking the lead on trying to identify which apps on their networks are the most problematic, and then you know, aggressively following up with those. But unfortunately, most of the time that's done post-launch. It's done after the app is out and started to interact with the network, whereas they would like it to be much earlier in the process, you know, during the development phase. That's actually a key reason in my mind why VoLTE and RCS are so important, because they provide an avenue for the operators to essentially take back control of the user experience in a way that you know, they can essentially optimize interaction of their own app with the network versus you know, being subjected to an OTT app, you know, interacting with the network in a way that, you know, they have very little visibility to until it's too late. So that's another key driver for why VoLTE and RCS are so important to the industry.
Okay. Yeah, I think that's definitely something that was touched on in the report as well. Gentlemen, I'd like to ask each of you to take a look forward for me. And Mike, I'd like to start with you and ask you, what are some specific technology updates in the next, say, 6 to 18 months that are going to create new challenges for testing?
Okay, to begin with, if you sort of take a look at the short-term view, we've touched on a lot of these subjects during this webinar. So there's IMS testing, there's VoLTE testing, RCS testing. With this, you then get the interaction of Wi-Fi offloading, so offloading traffic from LTE to the Wi-Fi technology. So all of those items are hot right now. You've also got increased number of bands, so more bands, which means additional RF testing, and that's further compounded with carrier aggregation. So we're already seeing 2cc downlink carrier aggregation dominating the testing world, whereby you can see things like 30 megahertz total bandwidth on the downlink with some 450 megabits being tested. So this impacts RF testing, performance testing, and then when you mix that with the numerous number of RF bands and coming up with a device that can really have global roaming and deliver the same data performance no matter which country or continent it's in. Going beyond that, I would say that there's items around high power UEs, which is an LTE Release 11 feature. This is focused at the public safety FDD14 market. On top of that, there's further enhancements to get the data rates up. So you'll start to see things like 3-component carrier downlink carrier aggregation. Also, you'll start to see 2-component carrier uplink carrier aggregation, providing 40 megahertz total uplink. These bring more testing challenges. Further on, I would say there's more features for the public safety market of device-to-device communications. So this is whereby devices can talk directly to each other without having to go to be in through any of the core network. So that brings additional challenges and new features of device discovery, etc. Therefore, what I would say as a test equipment provider, it's very important that test platforms can evolve with these new technologies. And ideally, you do not want to need to replace the entire equipment for something new. This helps keep costs down, the learning curve down for engineers.
Okay, Amit, I'm going to pose the same question to you, and then Carl, I will pose it to you as well. So, what do you see in the next 6 to 18 months as challenges? Okay,
so there's I would say three areas of challenges. One is on the network side, you've got LTE Advanced. That's coming at like a freight train, and a lot of the reason for that is basically operators aggressively trying to keep ahead of consumer demand. I don't know if you saw the report today. Cisco's Visual Network Index showed that mobile data traffic grew something like 80% year on year. So that demand is growing insatiably, and they're running out of spectrum, and so something like carrier aggregation is going to be extremely important, and that is, as we all know, can be very challenging to test when you're trying to bond, disparate frequency bands together. A second area is in terms of applications. I think that between the operator, the OEM, and the app vendors, they're going to increasingly try to serve more and more of our lifestyle through mobile apps. So there's a lot of discussion about wearable technology, but ultimately that's a conduit for things such as better kind of health management, as well as ultimately things like mobile payments, and those are just kind of going to grow the needs for testing, particularly on the application side. And then the last thing that I think is kind of this, it's something that a lot of folks aren't focusing on very much, but the fact that in December, the Chinese regulators released spectrum for TD-LTE in China. Up until today, the U.S. has far and away been the leader in terms of LTE, covering more POPs than any other country. Well, with that flick of a switch, a lot of attention is going to switch to China, where China Mobile alone has more subscribers than the entire U.S. population, as well as TD-LTE as a technology. So that those I think are going to have a lot of reverberations across the entire global device and app ecosystem.
Okay, great. And yes, we did. You can read about the Cisco report on RCRTV.com. Carl, your predictions for the next 6 to 18 months in terms of challenges and trends.
Well, I think both Mike and Amit told us about the freight train coming at us, which is carrier aggregation, and that's going to present a lot of challenges. Where I think another thing that we have seen recently is you're starting to see demonstrations of EMBMS. We saw that around the Super Bowl, and I know we don't want to talk about specific operators, but anybody who has looked into technology knows what was going on there. And that's not really an app per se in the same sense that a video streaming app would be, because EMBMS does require some protocol changes for LTE. But that's going to put a whole bunch of content in the hands of a lot of people on a lot of devices, and things like your battery life are going to start being impacted by that. And then you'll start having interactions with multiple applications, and it'll circle back to some of the things that we'd already talked about. But to point out something that Amit had said earlier, this does give the operators a little more control over some type of media distribution, because they can manage it. Now, I'm not sure what they can do about it, but it's easier to manage than random applications going to a server somewhere in the sky. So I think that all of these things keep adding together. Don't just multiply the complexity for testing and integration, but they add another exponent to it.
Okay. Great. Well, I've been joined today by Amit Malhotra, who's Vice President of Marketing and Product Management for Azimuth Systems, Carl Anderson, who is Senior Business Development Manager at Anritsu, and Mike Thorpe, who's Product Manager for Rohde and Schwarz. Gentlemen, thank you so much for the conversation today.
Thank you, Kelly.
Thank you.